Hello everyone, this is CSM mock midterm 2 video walkthrough for question 6.1 and 6.2. Let's look at the question first. So for this question, it basically asks us, given a representation of disjoint set trees, is it possible to obtain that tree via a series of connect operations? And it also mentioned that it is an instance of weighted quick union. Let's just look at the question 6.1 first. 6.1, tree 1. And then here is the tree representation. Let's just try to create such a tree through a series of connect operations. So look at node 1 and 0. We can do that by just call connect node 1 to node 0, node 1 to node 0, which is going to give us something like this. And then now look at node 2. We can call node 2 connect to node 1 or connect to node 0. In both cases, it's going to give us something like this. However, when we move on to node 3, we're going to find that no matter how we call the connect function, it's going to give us something like this. Because if you call connect 3 to node 3 to node 2, since the root node of node 2 is 0, it's going to connect node 3 to node 0 instead of node 2. It's the same case for node 1, also the same for node 0. However, in the given graph representation, we actually want to connect node 3 directly to node 2 instead of to node 0. And then to do that, before we call node 2 to connect with node 0, we first want to call connect node 3 to node 2. And then now we can call connect node 2 to node 0, which is going to give us something like this. So notice that it's an instance of weighted quick union. Every time when we call connect, we're going to compare the tree size because we want to connect the smaller tree to the larger tree. And then in this case, since both trees have size of 2, if we just call it connect 2 to 0, it's going to give us something like this. And then now let's move on to node 4. We can see that something similar here. That is node 4 has a bunch of nodes connect directly to it or like under it instead of connecting directly to node 0. So to do that, before we connect node 4 to node 0, we want to first create this tree. To do that, I can call connect node 5 to node 4, and then call connect node 7 to node 6, and then call connect node 6 to node 4, which is going to give us something like this. And then now we can call connect node 4 to node 0, and then since both bar has the size of 4, it's going to be something like this. And then now let's move on to node 8. It's also similar here. There are a bunch of nodes connect under the node 8 instead of connected directly to node 0. And then to do that, we can call connect node 9 to node 8, then connect node 11 to node 10, and then connect node 10 to node 8. And then we're going to call connect node 13 to node 12, and then connect node 15 to node 14, and then now connect node 14 to node 12. And then now we can connect node 12 to node 8. And then we have two parts that has size of 8. We can call connect node 8 to node 0. It's going to give us something like this. And this is exactly the same graph representation as what we're given here. Therefore, for the question 6.1, the answer is going to be yes. And then now let's move on to question 6.2. For this part, the answer is going to be no. Let's look at the array representation first. We can see that it's an array of length 3, which means we are given 3 nodes, nodes 0, 1, 2. That is the index of the array. Before looking at this case specifically, let's first look at an arbitrary example. So when we're given 3 arbitrary nodes, let's just first connect, and then now we want to connect all 3 nodes. So we're going to start from first connecting 2 of them. It's going to give us something look like this. And then now, when we're trying to connect the third node to the previous 2 nodes, we're going to find that no matter how you call the connect function, it's going to give us something look like this. Because it's going to connect this third node to the root of node it's being connected to. Therefore, the true representation is going to look like this when you're trying to connect 3 nodes using weighted quick union. So now let's try to give an array representation for this tree specifically. If we look at the root node, the value is going to be -3 because for a root node, the value is going to be the negative value of the tree size. The tree size here is 3. Therefore, the value is going to be -3 for the root node. And then now when we're looking at the 2 other nodes, we're going to find that they are going to have the same value since they share the same root node here. So it's going to be a graph representation look like -3 and then x. If we look at the given graph array representation here, it does not satisfy what we have right here. We can tell that it's not possible to have such an array representation. Apart from using this arbitrary example, we can also just try to do that directly when we're giving those 0, 1, 2. So we can first tell that 0 is going to be the root node since it has the negative value. Therefore, we're going to try to connect node 1 to node 0 and also node 2 to node 0. Let's just try those two orders. Let's just try to connect node 1 to node 0 first. It's going to give us something like this. And then now when we're trying to connect node 2, it's going to give us a graph like this. If you call connect 2 to 1, since the root of node 1 is 0, the node 2 is going to be connected directly to node 0. Let's just look at the other case. If we call connect on node 2 to node 0 first, it's going to give us something like this. And then if we called connect node 1 to node 0, it's going to be something look like this. And then similarly, if we call connect node 1 to node 2, it's also going to give us a graph look like this. No matter in which case, the array representation is going to be -3 and then 0, 0. Since for both node 1 and then node 2, they both have the root node 0, which is also distinct from the given array representation. Therefore, for the question 6.2, the answer is going to be no.